Hey, GED students, welcome to virtual GED class. Today, I want to talk about one of the most misunderstood concepts in basic math, and that is the order of operations. It really is something that is poorly taught, and so students end up confused. My big problem here is that most teachers teach you using this little mnemonic, as we call it, this little memory device called PEMDAS. I hate PEMDAS. It's the thing my husband and I fight about most often. He's an 8th grade math teacher, by the way. Really don't like PEMDAS for a couple of reasons we'll get into. If you have no idea what I'm talking about right now, you're like, Kate, what's PEMDAS? Well, good for you. You won't have to unlearn crap. But if you're like most students who are really super pro PEMDAS, you're going to have a couple of things to unlearn. Now, okay. In fact, one of these days, I'm going to write this book, I swear to goodness, called PEMDAS and Other Lies Your Math Teacher Taught You. It's not going to be a bestseller because who reads books about math? But seriously, it is that irritating to me. So what is Kate even talking about? Can we get to the point here? What is even the order of operations? If it isn't PEMDAS, what is it? This is where you're going to want to start writing things down. The order of operations is the order in which we simplify. And there I go, using math terms perhaps you don't know. But simplify is a pretty simple term. Let's come back to it. Let's get our definition down first. The order in which we simplify expressions. Oh, there I go again with my math talk. With more than one operation. Woo! 3 math words in one sentence. Holy moly. Let's make that make sense in English. First of all, let's just start with what is an expression. Usually you guys refer to an expression as a problem, but an expression is just some mixture of numbers and operations or operands, mathematical symbols that tell me to do something. Here, let's look at this one. 42 minus 5 times 6. This is an expression, what you think of as a math problem. And as you notice, probably, I hope, there's 2 operations here. There's more than one operation. There's subtraction and there's multiplication. And most students' default would be just to work it the way I read it. Let's go from left to right and start with 42 minus 5. And that student would be incorrect. They would not understand about the order of operations. The order of operations is like gravity. Anytime we're simplifying, and that means obeying those operations, okay? Simplifying just means doing that subtraction, doing that multiplication. So anytime we're simplifying, we are going to follow not left to right, but we'll follow the order of operations. That trumps every time. Now, later on in math, you'll learn some other things that are equivalent. They give the same answer as doing the order of operations, and so you're allowed to use those as well. But the order of operations is it's the law. It's the thing we can't get around. We either have to use it or use something that does the same thing. So we've got a student here with us today helping us to make sense of this because y'all know I like to talk too fast. So Cynthia's up in here for you guys, making sure that I make sense. She gonna check me. We're glad she's here. Cynthia, did somebody teach you PEMDAS?
Yes, they did.
I'm gonna work on my anger issues, Cynthia. I'm just working on forgiveness. Okay, I struggle. I'm sure Miss Johnson was very sweet. She probably did bring you cookies. She was probably lovely, but she just really didn't understand the order of operations. So if it isn't PEMDAS, what is it? Well, the first thing you're gonna notice here, I hope you notice here, is take a look at my screen. Notice how many steps I have here. 4 steps. 4 to the order of operations. I want you to count the letters in PEMDAS with me, please. P-E-M-D-A-S. That sounds like there's 6 steps. That's my first problem with PEMDAS. There's not 6 steps to the order of operations. There are 4. My second big problem, take a look at what I'm telling you the first step is. I'm telling you the first step is not parentheses, like some of your teachers will tell you. I'm saying it's groupings. Now, I get it. People tell me, potato, potato, Kate. Isn't a parenthesis a grouping? And I say, sometimes, but not all parentheses are used for groupings, and not all groupings are in parentheses. Let me prove to you what I'm saying. First of all, let's address that fact that not all parentheses are grouping. Now look at 2 different mathematical expressions. We have this 3 with the parentheses and then the 6, and then this 3 minus 6 plus 5. Only one of them, though, has a grouping. Do you see which one has a grouping, Cynthia? Left expression or right expression?
The right.
The right. What am I saying is it's a grouping? I'm saying there's something to do inside of the parentheses. There's something to do in there. There's an operation in the parentheses. That's a grouping, when there's something to do inside. And so when I'm talking about groupings, I'm talking about insides of things. So that's one thing. Not all parentheses are groupings. On the other expression there, this just says 3 times 6. There's nothing to do inside the parentheses, so there's no grouping there. But then I also said that not all groupings are inside parentheses. They can be inside lots of things. You can see a grouping inside of brackets. For example, if I had a problem that looks something like this, 5 minus 3 minus 6, I would want to start inside those brackets with the 3 minus 6. And I know, I feel the internet. I feel all you guys' anxiety rising, like, 6, I can't do that. Don't worry, I'm just telling you where I would start, guys. I would start right here. So we could use brackets to signify a group that we'd like to start with. Okay, so parentheses, brackets, but those aren't even the only way. I've seen math to do inside of square roots. I've seen it inside of absolute value bars. And even a fraction bar can be used to group a natural top expression and a bottom expression. So anytime we have a grouping, start there. Do that first. Work from inside to outside. So that's the first step, not parentheses, groupings. And now let's move on to the second step of the order of operations. The second step then is exponents. Most people know that these little floating numbers, also called powers, are exponents. But what a lot of students forget is the inverse of those little floating powers. Do you know that what the inverse of those little floating numbers are?
Yes, the square root.
Roots or radicals, square root being the one we're most familiar with. And they look like those little check mark houses. The two, you only see 2 on the GED. You'll see square root. It has no number in the check mark. And then sometimes on the no calculator section, you'll see cube roots come up, the opposite of the third power. But you'll just see that little 3 in the check mark. So it looks the same. If you see the check mark house, that's a root. It's the opposite of a power. So that's the next step. Now, the third step to the order of operations. What is it, Cynthia?
It's multiplication and it's inverse.
Beautiful. And I'm so glad, I kind of gave her a cheater because I flipped it too early, but I'm so glad that Cynthia said multiplication and it's inverse. You know, I said that's my other problem with PEMDAS. It makes like there's 6 steps. There's only 4 steps. Multiplication and its inverse. What is the inverse of multiplication, Cynthia?
Division.
Division. They happen on the same step. And you might say, well, okay, does that really matter? Well, absolutely, it sure does. Because when you're on the same step, that's the only time. I say it again, write this down. This is so important. Can you tattoo it on your foreheads, guys? It's the only time that you simplify left to right is when you're on the same step. So if I have both multiplication and division in the same problem, that is when I move left to right. I'm going to give you a really common error that students make is on a problem like this. If you've learned PEMDAS, not your fault. Miss Johnson taught you. I know how she is. Miss Johnson's sweet. She just didn't know, right? She's not a mathematician. But a lot of students say, well, I'm going to start with the multiplication. But those students would be wrong because the 2 operations we see here, multiplication and division, are inverses. We are going to work them left to right. We're actually going to do the 12 divided by 6 first. So 12 divided by 6 is
2.
2. I'm going to drop down anything I haven't used yet. So I replaced 12 divided by 6 with a simpler version, 2. And then I'll drop down whatever part of the expression I haven't used yet so that each line is equivalent. We are so obsessed with equivalence, things being equal in math. And now we know what to do. We can see it. 2 times 2 is 4. Beautiful. Now I know. You're going, Kate, really doesn't matter why you're a mathematician so anal. Y'all drive me crazy. I want to do it my way. I want to do multiplication first. All right, let's try. 6 times 2 is 12. Drop down the divide I haven't used. Drop down the 12 I haven't used. And 12 divided by 12 is 1. Uh-oh. Those did not give me equivalent answers. They can't both be good methods. Okay, guys. Same step, go left to right, not multiplication before division. Beautiful. Glad to clear that up. Super common issue with students who don't fully understand the order of operations. So last and final step, after we've done multiplication and its inverse, hook it up, Cynthia. What do we do next?
We do addition and its inverse.
Beautiful. Addition and its inverse. Cynthia, do you know what the inverse of addition is?
It's subtraction.
It is subtraction. So we have addition and subtraction. And it's really kind of like our order of operations is the opposite in which we've learned it. You know, we started with addition and its inverse in elementary school. Then we kind of moved on to multiplication, division. We got more complicated with our exponents. We started seeing some groupings. Okay, we're going to work kind of backwards, back to the basics. So we have addition and its inverse. And again, we're on the same step. So if I have both going on in the same problem, which do you think I should handle first?
The subtraction.
Yeah, why?
Because addition and subtraction are inverses, but whatever comes first, we would work on.
Beautiful. When you have two operations that are inverses, they're part of the same step, then and only then I will move left to right. So we would do 15 minus 5 first. Of course, that would be 10. Then we would add our other 10 and get 20. Beautiful. So same step, left to right. Okay. 4 steps to the order of operation. Okay, I get it. The reason why you liked Miss Johnson's PEMDAS is because it was easy to remember. And you're looking at this right now and you're like, Kate, there's a lot of words here. I kind of want to vomit. If you need a mnemonic, if you must, please don't use PEMDAS. Use GEMA. Okay, my husband might not agree with me, but the National Council for Teachers of Mathematics does. So I win. GEMA's a better way to remember this. We'll do any of our groupings, literally any of them. Okay. Then we'll do exponents. Then we'll do multiplication and division. And then we'll do addition and subtraction. This is the order in which we simplify. Whew, that was a mouthful. We've got to move on. Kate talks too much, as the whole entire internet knows. That is the most common complaint I get on my videos. And by the way, if that's what you think, that's fine. Like there's 1,000 teachers who teach the normal way. Go listen to them. They're great. They're super fast. But it is time now, Cynthia. We do need to move on. We need to work some problems. Let's give them a try. Let's start with some simple examples, some beginner level practice. Just kind of work out the kinks of this thing. I have 4 expressions here, 4 math problems, as you guys think of them. And you're going to notice that each one of the expressions has more than one operation. There's more than one thing to do. And we said the order of operations, it's like gravity. If we want to simplify, we want to obey these symbols, do what they tell us to do. And there's more than one of them. We need to follow the order of operations. So go ahead, read that first expression for me, please.
6 plus 9 times 2.
Wonderful. I see 2 operations there. What are they?
Addition and multiplication.
Addition and multiplication. Now, a student who'd never heard of the order of operations, which is like half the internet, if you look at those math things that go around, would probably just go, hey, left to right. But a student who understands the order of operations would start with the multiplication. We said we would do groupings. So I don't see any of those. Then exponents, don't see any of that either. But then any multiplication and division before we handle any addition and subtraction. So I'm going to box it up. For any of you guys who really struggle with your secretarial skills, your math grammar, using a different color to box this part of the expression up so you can focus your eyes on it can be really helpful. So let's start with simplifying the part of the expression in this box. Cynthia, what is 9 times 2?
18.
Beautiful. We used up this part of the expression, but you can see that there's a piece, a part that we didn't touch. It's super duper important that each new line be equivalent, equal to the line above it. So if there's anything we haven't used yet, you need to write it down on the next line. Now I know what you're thinking. Gosh, Kate, this takes so long. But the most common issue I see with students going into algebra is that they're really bad secretaries. So you need to have your skills straight now when it's simple, or when it gets hard, you're going to be in trouble. And now finally, it's easy to tell what to do now that I dropped my symbols. There's only one thing left to do. Let's do our 6 plus 18. You guys, a lot of you guys have the really bad habit of coming over here, putting plus 6 down there, doing some math vertically. Please, please do not mess up my beautiful mathematical communication with your side work. I literally do not care how you find out what 6 plus 18 is. I don't care if you count on your fingers. I don't care if you do scratch work. I don't care if you call your mama and you say, Mom, What is 6 plus 18? What I care about is that only your beautiful, simplified answer goes underneath. If you really need to do scratch work, don't mess up your gorgeous communication. Do it over here. But you can do that little algorithm that Miss Johnson probably taught you too, which she was better at teaching than the order of operations. Beautiful. Okay, one more thing I want to point out to everybody. Look at where my answer is. I don't really call it an answer. Mathematicians would say the simplified expression, but look at where the answer is. Do you see it? It's down there at the bottom. Guys, don't come up here and write equals 24 up here. Again, you're developing a really bad habit that's going to shoot you in the foot when you reach algebra. Mathematicians simplify down. We go down. We don't jump across equal signs unless we're solving. We're going to use that later in algebra. Okay, let's look at example 2. Cynthia, would you read that expression to me?
4 times 5 minus 3 times 4.
Okay, I see 3 operations here. Where should I start?
And the first multiplication where it says 4 times 5.
Beautiful, sure. So I can start with multiplication, which is supposed to happen before any addition, subtraction, 20. Now I have a lot of students who would then just copy down the rest of the expression because they say, well, Kate, you told me if I have the same step, multiplication, of course, they're on the same step. I should work left to right. But do notice, you guys, these 2 expressions, they don't touch. They don't share any numbers. They're not affecting each other. So you can just go ahead and do them both on the same step. Let's be lazy where we're allowed to be lazy. Let's be lazy where it won't hurt us. So 3 times 4, we can do as well here, 12. And you can see we replaced this part of the expression with something simpler. And we replace this part of the expression with something simpler, but we need each line to be equivalent to the one before. So we need to make sure that we don't lose anything. Cynthia, can you see the thing that we have above that we haven't dealt with yet?
Yeah, the subtraction part.
Yeah, make sure that drops down. Don't lose any symbols. Those are those secretarial skills that'll shoot you in the foot if you can't figure them out. Now, I don't care how you figure it out. I think I'll count up because it seems easier than side work. So from 12 to 20, I'm going to count up. This is a legit way to subtract, you guys. 13, 14, 15, 16, 17, 18, 19, 20. Real mathematicians use their fingers. Go ahead and take a look at example 3. Would you read that expression for me, Cynthia?
That says 8 minus 4 plus 1.
Beautiful. Now, a lot of students who have learned that mnemonic that I don't care for will tell me, hey, Kate, A comes before S. So I should start with the 4 plus 1. And I would say to them, there's something you don't understand. Cynthia, where should I start when simplifying this expression?
And the 8 minus 4.
Absolutely. Addition and subtraction are part of the same step. When we're on the same step, that is when we move left to right. So let's go ahead and do that. 8 minus 4 is 4. We've replaced this part of the expression with something simpler, but we need to drop down what we haven't used. And of course, we have not yet used the plus 1. And now it's easy to see what to do. 4 plus 1 is just 5. And my answer is at the bottom because I'm a mathematician, not a 3rd grader. And similarly, example 4 is another one that students who were confused would very commonly get wrong. They would want to do multiplication before division, but we know division and multiplication are inverses, which means they're part of the same step. And so we will just work left to right. And it does matter right now because they share a number. This 3 is being used in both situations. So order really is important here. So 12 divided by 3 will give me 4. Drop down the times 4 I haven't used. And of course, 4 times 4 is 16. Okay. Woo! We got the simple ones out of the way. So those nice 4 first examples were great for beginners. But hello, from lesson 2 of the crash course, we've been learning about another operation, those lovely exponents. And that, in fact, is the favorite type of expression on the non-calculator section for the GED. They love exponents. So expect exponents in some way needing to get simplified by hand. So we very frequently see exponents show up in our order of operations examples. Can you go ahead and read example 5 to me?
It says 5 to the second power minus 2 to the third power.
Beautiful. She could have also said 5 squared minus 2 cubed means the same thing, but we can definitely see those little floating numbers, those exponents. I see a couple of them right here and right here. Now you might say, well, which one do I do first? They don't share any numbers. They're totally separate from each other. So I can just go ahead and deal with both of them. So what is 5 squared, Cynthia? Please don't tell me 10. Please don't tell me 10.
25.
Thank you for not telling me 10. When you guys tell me 10, I want to cry. A lot of students will just revert to that means 5 times 2. 5 squared does not mean 5 times 2, right? It means 5 times itself, or 2 5s multiplying. Beautiful. 25. Then how about 2 to the third power? Some of you guys have your cubes memorized, but a lot of us don't. So once again, if you need to do your side work to figure out what 2 to the third power is by multiplying 3 2s, go for it, but do it in side work. Side work, side work, side work. Do you know what 2 to the third power is?
8.
Of course it is. 2 times 2 is 4. Multiply that by another 2 and I get 8. And I just write the simplified expression underneath, not my side work. Gorgeous. Now, I replaced the 5 squared with 25. I replaced the 2 cubed with 8. But, of course, I haven't used the minus sign. I drop it down, so my expressions are equivalent. And now I can do this math however I want. You can call your mommy. I don't care. But you've got to be able to figure out what 25 minus 8 is somehow. So why don't we just go ahead and use the subtraction algorithm? So I'll borrow. 15 minus 8 is 7. Drop the 1 and I get 17. Beautiful. 25 minus 8 is equal to 17. Let's go ahead and look now at example 6. Ooh, that one's a little tricky to read. Cynthia, do you think you can read it?
It says 8 times 1 cube.
Beautiful. I love it. A lot of students would say, hey, I have to start with parentheses. And they would want to start right here. And they would be incorrect. Why? Any thoughts, Cynthia?
I think we have to start with the exponents first.
Absolutely. Exponents are supposed to come before multiplication. Parentheses is not an operation, people. We'll start with our exponents. We'll start with 1 to the third power. Now, once again, I'm like, please don't tell me 3. Please don't tell me 3. Please don't tell me 3. Cynthia, what is 1 to the third power?
It's 1.
It is 1. If I take 1 and multiply it by itself 3 times, I don't really care how many times I multiply 1. I'm just going to get 1. Thank you. Now, this is an interesting question. Do I still need my parentheses?
Yes.
Yes, those parentheses were there to tell us to multiply, and we haven't multiplied yet. We still need a symbol for multiplication, so they are still there. And now, wonderful, I can see what to do. 8 times 1, of course, is just 8. Okay, so let's look at the next one. I'm so paranoid that this isn't going to show up in the video. I've had that happen before. So I think I have it turned off, but let me just rewrite it. So we have 4 squared minus the square root of 9. Any ideas where I should start with this expression?
I would start with the 4 squared.
Absolutely. We'll do exponents before subtraction. But that's not our only exponent, is it? Do you see it? The square root of 9, yes. And so they don't share any numbers. I can go ahead and do them at the same time. What is 4 squared?
16.
Thank you for saying 16. Thank you, Cynthia. Cynthia is my favorite. Look at that. She said 16, not 8, and I don't have to cry. And we said we're going to do the square root of 9 at the same time. What is the square root of 9?
3.
Beautiful. We've got a symbol that we haven't used yet. We need to have it still. And if we're good secretaries, we'll know exactly what to do and we don't have to guess. And of course, 16 minus 3 is 13. And our answer goes down because we're mathematicians. All righty. Ooh, looking good. This next one, super typical. This one comes up a lot in math classes. It's very likely to come up in those first 5 where you don't have a calculator. It would intimidate a lot of students, but it's not nearly as bad as it looks if you know where to start. Cynthia, where do you think I should start in example 8?
In the
Look, she's scared to say the word parentheses. She's so scared. You can say in the parentheses. You can say it. You know why? Because you said to me in the parentheses. We've got to start with the insides of groupings. And Cynthia's right. In this case, these parentheses are being used to group. It's not the only thing they're being used for, but they are being used to group, and we start with groupings. Wonderful. Look, I got you so scared you don't even want to say parentheses. It's like it's a cuss word. I'm a jerk. So yes, inside the parentheses, 4 minus 1 is 3. And then, do I still need my parentheses? I mean, I just dealt with that grouping. Are the parentheses being used for anything else?
Yes, they are.
They are. They're still being used to tell me what's being raised to the third power and to tell me about multiplication. That's a lot of communication. I'm not done with those yet. So then what should I do next? What operation should I handle now?
I would do the exponents.
Absolutely. Thank you. And you would be correct. If you started with the multiplication before the exponents, then you would be wrong. Remember, we do exponents before multiplication. And again, if you don't know what 3 to the third power is, I do want you to figure it out, but I don't want you making it all messy. Come into your side work to figure out what 3 times 3 times 3 is. 3 to the third power means 3 3's multiplying. So 3 times 3 is 9, but I still need to multiply by another 3, and I get 27. So 3 to the third power is the same as 27. But once again, I have to ask myself, am I done with the parentheses?
No.
No. See how versatile parentheses are? They get used for so many things. It's important to see that. So these parentheses are also telling me to multiply, and I haven't done that yet. So last thing to do is 2 times 27. And of course, if you have to do that math, that's side work. I don't care about it one little bit. And we get 54. And if any of you guys are out there like really stressed, like, I don't know how to multiply by hand, I literally don't care if you pick up your calculator and you do 2 times 27 right there. And you say, well, Kate, isn't this on the non-calculator section? And I say, yes, but you can completely and totally bomb the non-calculator section. You can do absolutely no math by hand and still get a very high score on your GED. But what you can't do is fully understand algebra without understanding the order of operations. So it's really the order of operations I'm more concerned about today. So do not let your times table be the thing that messes you up. We're working out the order of operations. That needs to be your first priority. Cynthia, I got super good news. The problems on the last page are the ones that are most likely to come up in the non-calculator section. So a lot of students will be like, I have to get to the hardest ones at the end. These other ones that we're going to practice for a reason, because being familiar with them will help you in algebra when we look at some things with some letters a little later. But it was the last 4 examples that were most GED-like for just straight order of operations problems. They're not really called order of operations problems, but the math that we have to simplify by hand most often look like those. But I still need you guys to stop panicking about fraction bars. So can we take a look at these 2 problems with fractions in them so you guys can like work through your fraction trauma? Okay. Example 9 and example 10 look very similar to people, and a lot of people would read it the same way. So I'm going to read them so you can hear the difference. On example 9, we have 30 divided by 10 plus 15 divided by 5. Now, you might say, well, how is that any different? It's about how long the fraction bar is. Remember, we said fractions can be used for grouping. In example 10, we have this whole group, 30 plus 15, divided by this whole group, 10 plus 5. So if I wanted to read this expression, I would probably say the sum of 30 and 15 divided by the sum of 10 plus 5. I'm saying take that entire expression and divide by that entire expression. And you say, well, does it really matter? And I say, oh yeah, it really does. In fact, that's why we start using the fraction bar instead of using the divide by symbol once we hit algebra, because we want to know exactly what's dividing by what. And that fraction bar makes it really easy to tell. So looking at example 9, where do you think I should start, Cynthia?
On the 30 divided by 10?
Absolutely. Just as a general rule, if we're looking at the order of operations, we do any multiplication and division before we do any addition and subtraction. So 30 over 10, stop panicking about it being a fraction. It's also a division problem, and it's really easy division to simplify. It's not going to stay a fraction because we know what 30 divided by 10 is. What's 30 divided by 10?
It's 3.
It's 3. And this 15 divided by 5 doesn't share any numbers, so we can do that in the same step. So 15 divided by 5 is?
It's also 3.
Also 3. Then I'm going to drop down any symbols I haven't used yet, like that plus, and I can just see that this is a really simple expression now. 3 plus 3 is 6, and y'all had trauma, panic attacks, probably in the fetal position in the corner over the fractions for no reason, you guys. A fraction bar just means the same as divide. Now the next one. Next one is enough to make some students want to puke. I mean, sincerely, some students would run out of my classroom, but Cynthia's brave. Cynthia's strong because she knows where to start. Cynthia, where should I start here?
We're going to start getting the sum of 30 and 15.
Let me just copy this problem down just in case I have this paranoia. You're absolutely right. Let's start with that sum of 30 plus 15. This fraction bar naturally groups us into a group in the numerator, the top, and a group in the denominator, the bottom. Some teachers will make you add parentheses. Those are those same teachers who taught you PEMDAS. You don't need parentheses. The fraction bar already does the grouping. Okay, so yes, Cynthia says, let's start with the 30 plus 15. Now, for my students who have issues with symbols like the numbers dance and play, I know there's a lot of you out there. This is the only time I might recommend going across for you guys, because sometimes it makes it easier for students to see with the fractions that I went on the top and then I went on the bottom. I'm not going to do it that way, but if you're really getting all twisted up in numbers, you can go across if you really need to, okay? But I'm not going to, because that's not the way mathematicians normally do it. We normally simplify down. 30 plus 15, yes, is 45. But that wasn't the only group here. I had another group. Cynthia, right? What was my other grouping?
The sum of 10 and 5.
Beautiful. Oh, she sounds like such a mathematician. The sum of 10 and 5 is 15. So I wrote that down. But there is a symbol that I must not lose, even though I hate that symbol. I don't. You guys do, though. What symbol am I missing, Cynthia?
The fraction, which also means division.
Exactly. The fraction bar, which also means divide by. So 45 divided by 15. And some of you guys are like, I don't know my 15 times tables. Yeah, this one's not going to be hard, guys. If you are that stressed out about it, you could literally add up 15s. That's the same as counting by 15s. And you would get to 45 pretty darn quickly. And you would be able to see that that's 1, 2, 3 15s. So how many 15s are there in 45? There are 3. Okay, Cynthia, I'm being mean. I'm not going to lie. Example 11 is meant to do 2 things. This is actually harder than anything you would probably see in the first 5 section where you don't have a calculator. So if something came up like this, you would have a calculator. But something like this will come up when you go to do what's called solve quadratic equations. And I need you not to panic and vomit when you do. Okay, so you will have a calculator, but yet you still could simplify this sucker by hand using the order of operations. I mean, honestly, the main thing I'm trying to do here is to get you not to panic when you look at something like this. This looks so gross. But I need you to see that there's a grouping. There's something happening on the inside. Can you see this grouping in this nasty expression?
Inside the square root thing.
Exactly. Not inside the parentheses, because there's nothing in there. You know, there's no operation in there. But yes, absolutely. Inside the square root. That's where we should start. Beautiful. Now, there's a lot of math even in there, so a lot of students would still struggle. But even inside of groupings, we follow the order of operations. So looking inside of there, where would you want to start?
Doing the exponent.
Brilliant. I get 5 squared. A simpler way to say that is 25. Now, I got super good news. You can just copy down the rest of this expression, okay? However, I can see that the next thing I would do, the multiplication, is not touching the 5 squared. They don't share any numbers. And so it would be totally fine to do this at the same time. Now, for those of you who are like, Kate, whoa, that escalated quickly. This is advanced level problem. Again, this is harder than what you're going to see on the first 5. You can turn off the video, go sip tea, and ignore me now. It's a really good day. But for those of you who want to up your game, we're just flexing those order of operation muscles, okay? Now, super important to drop down anything I haven't used. So I used the 5 squared. squared and I used the 4 times 4, but I haven't used the minus, and I haven't used the square root, and I haven't used the 2 cubed, and I haven't used that minus. Whoo, scary. Now what, Cynthia?
Now we still need to figure out the stuff inside the square root.
There's still more in that grouping to do. We're just going to keep chipping along at that grouping. Cynthia's absolutely right. 25 minus 16. And this is the thing, I'm not going to mess up on the internet. I know it's 9 and not 11. Okay, wonderful. Sorry, messed that up in my last order of operations video. There's a reason we're remaking, guys. Now, I am going to just drop. Now, some of you guys know that we can kind of cheat and do some of the other math, but I am not going to muddy the waters right now. And so I will drop everything I haven't used up yet. Now I've dealt with all my groupings. Now there's nothing left to do inside of that square root symbol. What should I do now, Cynthia?
Since they're part of the same step, I would start from left to right.
From left to right with what?
With the 2 cubed.
The 2 cubed and the?
And the square root of 9.
Root of 9. Okay, wonderful. Those two exponents and radicals are part of the same step. We can go left to right, but we could also just do them both at the same time because they don't share any numbers. So the whole left to right thing is, I mean, it's fine if you do it, but it won't matter. 2 to the 3rd power, we did that before, but once again, that's 2 times 2 times 2. So it's not 6, it's 8. And the square root of 9, we're asking what number times itself equals 9. Of course, it's 3. And we'll drop down what we haven't used up. And 8 minus 3 is 5. And it's not as hard as it looks, guys. Don't be intimidated. I always tell my students, you don't have to know everything to do. You just have to know the first thing to do. And then if you have decent secretarial skills, it all drops down and you'll know the first thing to do then. And the first thing to do then. And before you know it, it's done. And it's not nearly as complicated as you thought. Whew, we did hard math. Now, the next one I have on the advanced level practices on the crash course, just because I need you guys to not panic at the sight of absolute value bars, but you probably won't see this on the GED just like this, okay? We do get absolute value on the GED, but not usually in this context. But I just need you to see that the rules we've been learning really do apply here, and it's got some fun little tricks to it. So I find it a really good exercise builder. So that being said, I said you don't need to know everything to do. You just need to know the first thing to do. What do you think the first thing to do here is? Oh, I miswrote this problem.
Yeah, that's what I was going to ask.
Oh my gosh, thank you for catching me, because that would have made it very tricky with the order of operations. Whew! See, Cynthia's watching out for you guys. I was talking crap about you guys' secretarial skills. Who has the issue now? Okay, where do you want me to start, Cynthia?
I would start with the exponent.
Yeah, absolutely. You can see we have a natural grouping here. We have some stuff happening on the inside. And of those two operations in there, subtract and this power, absolutely, we have to start with exponents. So let's deal with that first. So 2 squared is 4. I used up this piece, but now I need to drop every single thing I didn't use. Do I really have to, Kate? That takes forever. Yes, you do. Yes. Your secretarial skills will make or break you in algebra. It's a language and you need to speak it. Oh, sorry, I have a little hissy fit about that every time. Okay, Cynthia, you don't need to know everything to do, but you do need to know the next thing. What should I do next?
Work inside the absolute value.
She's right. We haven't completely dealt with the insides yet. Now, there's a reason why I have this in advanced level practice. Now we're getting some negatives coming up. We have not seen negatives before. If you don't know how to add and subtract negatives, it's really not that big of a deal. Like I said, most of the time you're doing that on the GED, you'll have a calculator. But Cynthia and I are doing challenge level work. Cynthia, do you know what 3 minus 4 is?
It's -1.
Oh my gosh, Cynthia, you must be a mom. Cynthia knows how it is. If you have $3 in your bank account and you spend 4, you go negative. And then the bank probably charges you even more money, but that's another word problem. All right. So yeah, you have 3 things and you go ahead, you go down by 4, you're in trouble. You just went negative. But I have some things I need to drop down from above. I used 3 minus 4. What do I need to keep? What symbols do I still have?
We need to drop down the absolute value bars and -4.
Good. Now, a lot of students really confused right here. Don't know what to do, but I see 2 operations. I see absolute value of -1 and I see this -4 shoved up against that absolute value. Cynthia, do you know what's happening when two things are shoved up against each other?
They're multiplying.
They're multiplying. So there's two operations left. There's absolute value and there's multiplying. And darn it, GEMA doesn't have absolute value bar. Absolute value, we're going to do, treat it like it's the same step as exponents. And remember, I told you it's kind of like the opposite order of which we were learning it. And so it's kind of up there with those higher order operations. So we'll do it now before we deal with our multiplying. Do you remember what absolute value does? We kind of touched on that in lesson 4, but if you weren't in the advanced level practice, you might not have practiced it so much.
No, I have no idea.
Okay, when I ask you the absolute value of -1, I'm just asking you, how far away is -1 from 0 on the number line? And you're like, stupid question, Kate. It's over there at -1. Yeah, but it's distance I'm asking you. So how many jumps away? It's just 1 jump away. And so absolute value bars just basically make their insides positive. That's all they ever do. They make their insides positive. If it was already positive, it'll still be positive. So you used up the absolute value when you found the absolute value of -1. But we have a problem. If I just drop this -4, I'm like, what are the -4 and the 1 doing? So we got to not forget what they were doing at the step before. What did you tell me they were doing before?
They were multiplying.
They were multiplying. And so I'm going to put parentheses here just so I know what I'm doing. I need some kind of a symbol that says I haven't done multiplication yet. And now we can do our final step. -4 times 1, of course, is just, I ran out of room, -4. A lot of students will tell me, you can't have a negative answer. There were absolute value bars up there. Yeah, they worked on the -1. They weren't on the whole problem. Okay. All right. We're done. Woo, we did so good. I feel smarter. How do you feel?
I feel great. I think I did good.
Excellent. I think you did well as well. And I think all of y'all did well, but I think y'all need to practice because you got a problem. I'm sorry. I'm not trying to be mean, but this is what happens. You guys are like, Kate, you were such a good teacher. I totally understood it. I don't have to practice. And I say that I appreciate the compliment, but if you don't practice, you won't remember it come test day. You just won't. And so go pick your level of practice. I don't care what level it is. Go ahead, make sure that you practice so that you make strong pathways to that knowledge in your brain so that you remember it come test day. All right, you guys, happy learning.